Sunscreen is one of the most recommended health products on Earth. It's also one of the most controversial. Some people believe it protects you from cancer. Others believe it might be causing it. And here's the strange part. Both sides can point to scientific studies. So who's right? Today, we're putting sunscreen on trial. Not to decide whether you should use it, not to tell you what to put on your skin, but to answer a much bigger question. How would we even know if sunscreen causes cancer? In 2019, FDA-related studies found that several sunscreen ingredients could be detected in people's bloodstreams after repeated use. Not estimated, not suspected, measured. For many people, that's where the story ends. Chemical enters blood, blood goes everywhere. Therefore, chemical must be dangerous. Sounds reasonable. But science doesn't work that way. Because detecting something in the body and proving it causes harm are two very different things. And that difference is where this entire debate lives.
The fear didn't come out of nowhere. Certain sunscreen ingredients have genuinely raised questions among researchers. Oxybenzone has been studied for possible hormone-related effects. Octocrylene can slowly break down into a compound called benzophenone under certain conditions. These aren't conspiracy theories. These are real scientific questions being investigated by real scientists. The problem is that somewhere between a scientific question and a social media post, an important step often gets skipped. A question becomes a conclusion, and that's where things start getting messy. Most people accidentally jump from step 1 to step 4. Scientists detect a compound. The internet hears danger. But between detection and disease are several critical questions. How much entered the body? Where did it go? How long did it stay there? Did it interact with anything important? Did it actually cause biological damage? Because detection is not proof of harm. It's the beginning of an investigation, not the conclusion. Modern instruments are incredibly sensitive. They can detect tiny amounts of substances at levels that may never have meaningful biological consequences. Finding something is not the same as proving it's dangerous. Whenever researchers discover a potentially concerning effect, they ask another question. What dose produced that effect? Because dose matters. A lot. A compound can be harmful at one level and harmless at another. Even water can become dangerous if consumed in large enough quantities. So when you hear that a chemical has been linked to cancer concerns, scientists immediately want to know much more. How much exposure? For how long? Under what conditions? In animals? In humans? Through the skin? Through food? Without those answers, you don't yet know whether you're looking at a meaningful danger or simply a measurable exposure. Now we arrive at the hardest question in the entire video. Suppose sunscreen really did increase cancer risk. How would scientists discover that? Would cancer cases appear immediately? 5 years later? 20 years later? Would everyone be affected, or only people with certain genetics? Would the effect be large enough to notice, or small enough to hide among hundreds of other factors that influence cancer risk? Cancer is one of the most difficult diseases to study because it rarely has a single cause. Age matters, genetics matter, lifestyle matters, environment matters, random chance matters. Which means proving that one specific thing causes cancer requires an enormous amount of evidence. Much more than a scary ingredient name on the back of a bottle. Science has been wrong before. This is where many people stop trusting science. They point to smoking, or asbestos, or leaded gasoline. And they're right. There was a time when cigarettes appeared in advertisements featuring doctors. There was a time when asbestos was widely used. There was a time when lead was added to fuel around the world. Eventually, the evidence became overwhelming. The conclusions changed. But notice something important. Science didn't fail. Science corrected itself. The reason we know those things were harmful is because researchers kept testing, questioning, arguing, and collecting more evidence. Science isn't a collection of permanent truths. It's a process for reducing uncertainty. And sometimes, that process changes its mind.
Science isn't certainty. People often imagine science as a giant book of facts, but that's not really what science is. Science is a confidence machine. Some conclusions have extremely high confidence. Others have moderate confidence. Others are still being investigated. The question isn't whether science has ever been wrong before. The question is how confident we should be about the evidence available today. And that's exactly the question we should ask about sunscreen.
At this point, someone usually says, "Of course scientists recommend sunscreen. The sunscreen industry makes billions of dollars." And that's true. The sunscreen industry is extremely profitable. Companies benefit when consumers buy more sunscreen. But here's the problem. That fact alone doesn't tell us whether sunscreen is harmful, because there are other groups making money too. Wellness influencers, alternative skincare companies, supplement brands, content creators. Fear can be extremely profitable, sometimes more profitable than the product itself, which means financial incentives exist on both sides of this debate. And incentives alone don't determine who's right. Evidence does.
Why marketing makes this hard? Marketing loves certainty. Use this product. Never use this product. Sunscreen is essential. Sunscreen is poison. Those messages are easy to sell. Uncertainty is not. But uncertainty is often where the truth lives. Reality is usually more complicated than the people selling answers want you to believe. And that complexity is exactly what makes this debate so difficult. So far, we've spent most of our time questioning sunscreen. Now let's question the thing it's supposed to protect us from: the sun. Because if sunscreen is on trial, the sun deserves a seat in the courtroom too. Ultraviolet radiation carries energy. When enough of that energy hits skin cells, it can damage DNA. Most of that damage gets repaired. Sometimes it doesn't. And when DNA damage accumulates over time, the risk of cancer can increase. This isn't a brand new theory. Scientists have been studying the relationship between ultraviolet radiation and skin damage for decades. Comparing the evidence. And this creates a very interesting imbalance. Researchers continue studying sunscreen ingredients because questions remain. But the evidence connecting ultraviolet radiation to skin damage and skin cancer is currently much stronger. That's not an opinion. It's simply where the evidence stands today. One side of this debate still contains unanswered questions. The other side contains decades of accumulated research. That doesn't automatically end the conversation, but it is an important fact. One of the strongest arguments skeptics make is also one of the most intuitive. Humans lived for thousands of years without sunscreen. That's true. They absolutely did. But they also lived without antibiotics, without modern cancer diagnosis, without modern life expectancy, without modern leisure tanning culture, and often with very different clothing, lifestyles, and working conditions. The past isn't a controlled scientific experiment. It's a completely different world, which means it can't answer today's question by itself. Let's ask a fascinating question. What evidence would actually convince scientists that sunscreen causes cancer? Large human studies showing increased cancer rates among users. Independent research groups finding the same results repeatedly. A clear biological mechanism explaining how it happens. A dose relationship where greater exposure leads to greater risk. This is the type of evidence scientists look for when establishing causation. Not headlines, not assumptions, evidence. So where does the evidence stand right now? Scientists know that some ingredients can enter the bloodstream. Scientists know that certain ingredients continue to be investigated. Scientists know that some compounds have raised legitimate questions worth studying. What scientists do not currently have is strong evidence showing that normal sunscreen use causes cancer in humans. That's the current state of the evidence. Not proof of perfect safety, not proof of danger, just the best answer available today. The hardest part about science is that people want certainty. Science rarely offers certainty. It offers probabilities, confidence levels, best explanations. Sometimes those explanations survive for centuries. Sometimes new evidence forces revisions. That's not a flaw. That's exactly how the system is supposed to work, because every generation inherits a little more evidence than the last.
So, do sunscreen creams cause cancer? Right now, science does not have strong evidence showing that normal sunscreen use causes cancer in humans. What science does have are ongoing questions about certain ingredients, active research, and a long history of changing conclusions when better evidence becomes available. At the same time, the evidence connecting ultraviolet radiation to skin damage and skin cancer is currently much stronger. The real lesson here isn't about sunscreen. It's about how science works. Science is not a collection of permanent truths carved into stone. It's a process for reducing uncertainty. The answer we have today is the best answer available today. Tomorrow, it may become more precise. And that's not a weakness of science. That's the reason it works. What you do with that information is your choice.